for the midterm, obviously, and the agenda for today is right here. Let's get this thing. I don't know. No. Yes. Keep airplane power mode enabled. Okay. Fine. So my plan is first of all to show you the new. Think about it, Catia interface, because the writing is on the wall. Catia is going to disappear as you know now. Okay. But if you know Catia, that'll give you a great deal of advantage to people who may want to use Catia later on, but the interface is completely different. Okay, and the reason is that these people at Dassault have bundled a whole whack of programs, such as Catia, with the excellent top-notch finite element analysis and maybe 500 other packages. Fluid flow, injection molding, optimization, social networking. It's not only engineering, marketing, and things like that. I'll show you the interface as long as I can run the power on this, and then I'll stop and ask any or answer any questions that you may have about the midterm. The midterm is straightforward. The problems are on the YouTube. Okay. I mean, a box becomes a circle, a cylinder, etc. But we're not inventing these things. These have been around for 40 years, 50 years. It's like taking a calculus class. There's nothing new. I mean, it has been done 200 years the way exactly it is. Just that you have to put the effort into it and stay with the class. That's all. Okay, now let me show you the interface, Catia interface. First of all, you log in. Everything is on the cloud. I mean, it used to be that people would get student license of Catia, for example. Or they would pay this much, $250 to send them something for a year, 2 years. I don't know. They don't do that anymore. They do it with a 3D experience, but the difference is that all the savings and everything is on the cloud. You still have to put the software on your computer, but the software is not on the cloud. You have to install it, but every saving that you do, no longer you can send files to people. Everything is up there. Now, so you have to be connected to internet, obviously, and then you log into your account, and what you get is uh, you get an interface, but then these are all the applications. On the left side is all the applications that you have. Now notice that I've selected some, my favorite one. Remember I was double clicking on this on the top right side, it'll give me my favorite one. These are the ones that I use, essentially. Part design, guess what this part design is? It's the Catia part design. Assembly design, same thing. Look at the icon. There's nothing to do with double gears anymore. Generative shape design. Okay, and these are the analysis, but the analysis is not your Catia analysis. It's a abacus analysis, basically. So I have done a part because I'm going to show you how to make a box with a hole, for example. Remember that problem that we did? Let's just go ahead and make it. And so I already brought up the part design. Look on the top, it says Catia part design. Catia part design. Okay. The tree looks familiar. Things look a little bit different, but there is an XYZ plane. There's a part body, you have a part body, etc. So let's say hypothetically on this vertical plane, I want to make a sketch, a square with a box, because I want to pad it later on. Look, these don't look familiar. Some of the icons may have changed, cosmetically, but I'm not going to worry about any dimension. But here, let me make a centered cube, right, or rectangle, right there. You remember this dimension, right there. Now in the Catia, I think that was called constraint. What is it called here? Constraints, the same thing. By the way, if you want, you can make the stuff show icons and text underneath it. So here is you can set it, the color of the screen and all these things. You can reset it. If you don't like it, you can change it. But anyway, so here's the dimension. Let's make this thing, I don't know, right there. I'll just put some dumb number here, 200, whatever unit is. There, you know that. Circle, right there, the different ways of making circle. Center, center and radius, there we are. By the way, they have made some changes here that are very useful. For example, when you draw a circle or draw a rectangle, immediately you may want to dimension it. So instead of going down there and trying to find the dimension icon, right there is something on the right-hand side that shows up. Unless you close it, right now you're going to dimension it. This is very useful, actually, okay? You have to double click on it, something opens up, and you have to change it. And here, as soon as you make a circle, right on above to the right, you get the possibility of specifying dimension. Exit. Remember the exit right there. It's the same thing. Same icon. There we are. Now, under the Essentials tab, the basic things that you do when you do part design. Okay. This is being recorded, so I might as well put it there. Pad, right there. Right there's the pad. Okay? And there is revolve, a shaft actually. Part design called it the shaft. Okay? Etc. And rib. Shape of the rib icon, they changed it. Padded. Now, this dialog box is essentially the same information, but there is no mirror extent. You can see that. But on down here, see that? This icon? It says basically mirror it. I'm going to select this. It does it on both sides. Instead of mirror extend, there, one side, two sides. Numbers are the same, exactly the same stuff. There we are. Splitting it. Well, the split, you have to become familiar with some of the stuff that is in these tabs. For example, if you go to transform, split right there, but it doesn't. It's not a saw anymore. It looks like that. Okay, you click on it and you read it carefully to see what it says. Down here, it says splitting element. One of these planes, for example, this one. You get your good old arrow here, except that you can see it right there. The arrow is over here. You can flip it, okay, and then say okay. Did it do it? I can't remember. The flipping of the arrow. This $1 mouse is not going to do me any good either. So let me see now. Well, I can't. You know what? Because let me delete this. Okay. So split. Uh, the only thing is that I don't know whether I did it. Oh yeah, I did it halfway. Mirrored it. So right there. There we are. Okay. You want to split it with other planes, the same story. So for example, here, split with this guy. I'll take the default stuff and split with that fellow, which is XY. There. Everything is the same. Done. You just created something in Catia part design, basically. And all you had to know is how the icons have changed from what you were familiar with to some of them. Some of them are the same, pad, stuff like that. But split, there was no saw there. Okay. Now, if you want to apply material from this point on, because we want to do FEA on it, for example. If I want to apply material, then there is no apply material icon the way you are using it. So you go to the tools, and down here, it say material browser. Oops, material browser. Well, you're right there. You can, if you already have material or other people have put material, given you access to it, you can go and find out which one you want. Otherwise, you create it right there. Okay, you create it over there. So let me quickly show you how you create an elastic material. Just click on it. You can give it a name. So June 16. Now, if you want, you can, let me click on it first of all. Immediately, it creates a material in the database right there. You can see that. This is all on the cloud now. This is all going to be stored there. If you don't want people to have access to a material, you should not give them access, collaborative access. There's a whole whack of stuff here. This is the one that I created. Of course, I haven't put any numbers in it. All I did was a name and a shell, basically. So if you want, you can right-click and say, okay, I want to define it. Here, you want to define it, basically. Or you can apply it and then go define it. It's entirely up to you. You can apply it, or you can define it and then apply it. So you click on it, structural, abacus multiphysics. You can see even the name, the name abacus is associated with it. Because this is exactly the interface that you see in the Abacus CAE program. If you're an Abacus CAE user, you know what this thing is. If you're a novice user, no user of 3D experience, you don't know anything about Abacus, forget it, there is your interface. So you go to mechanical, elasticity. Notice that here you can do elastic, hyperelastic, plasticity, all stuff. In Catia, all you can do is linear elasticity. Hyperelasticity is when you have rubber material, gaskets and things like that, gigantic compressions and things of that type. You can't do it in Catia. You know, if you can model it, but it's garbage, pure garbage. So you click on it, and it's very simple. Two numbers. For static analysis, you need two numbers. What are those two numbers? There's a whole whack of stuff here, but you need only two numbers. What are they? Good multiple choice question. Good multiple choice question. Okay, so Young's modulus, 200, for example, 1,000, what units are in megapascal here? So 200,000 megapascal, Poisson ratio 0.3. If you have dynamic, then of course you have to give it the dynamic or weight effect. You have to give it the density too. But I don't have it. Done. Now I create it. I put the number in there. I'm going to apply it. Right click, apply on that part. Let me close this. Did I do it? I think I didn't do it. So let me go browse it. Material browser. Right click. June 16, right? Come on. Right click. Apply. You close this and you apply it there and you say, okay, material appears right here, and you can go change it and things like that. You can go check it, add it, etc. You can modify it here. This is it. And now you're going to go to the basic stuff that we are doing in this course is right here, structural model creation. Meshing stuff is right here. First you mesh, and then you run. First you mesh, then you run. It's called structural model creation, structural scenario creation. Let me just first do the meshing. This is the basic stuff that we are doing, so I use the standard one. It says, do you want the swept mesh? In other words, a very nice four-sided element swept? Do you want the pyramids, stuff with the pyramids and things like that? The standard in Catia, you can do it like that. You see that? Octree tetrahedral element. So these are inherited from Catia, okay? But we're going to do a nice swept mesh that is not easy to do. What is this? Inside. All visible body, so I don't have to pick it. There's only one, and the size. Let's do 50 millimeters. See what happens. Size. Update. Horrible mesh. 50 millimeter was gigantic. Remember, the whole thing was 200 millimeter long. Remember? So let's go ahead and change this to something much smaller. This is right, but the size of the element is so big that you can't even see. So let's start off 50 millimeter. Let me put 5 millimeter. And this number 4 here is the layers through the thickness. The layers through the thickness. It says 4. You can make it to 7 if you want. Let's make it 7. You have linear or parabolic. This is linear. This is parabolic. And then mesh. There we are. You could have done that octree tetrahedral element, the one that you get in Catia. This is it. So notice that mesh is created, properties are created automatically. Do you remember that solid section? 3D, 2D, 1D is automatically created, just like Catia. And now that we are done here, we're going to go to this was the meshing. Okay. By the way, you can create several meshes and then use different ones. Okay. Let me go ahead and do the loads. Now remember, these things, loads and mesh and all these things are common to all FEA packages. Doesn't matter. Because after all, this is all the math end of it that's behind the screen. The CAD end are different. If you do it in AutoCAD, 3D version of AutoCAD, Catia, the one that's by Siemens NX, these are all different. CAD aspects are different. Okay. But here, okay, so let's select our mesh. Because we have created several meshes, you can select the one that you want. Maybe one is fine, the other one is coarse, etc. And then we say okay. And the bottom row changes to, these are called action bars. And you can move them around, by the way. That's a good thing. In Catia, you can move them around, which is good for some people, horrible for others, because you lose it, you close it. You can't close these things. These are basically your toolbars that appear in Catia. You can move them around. We are not in Catia anymore. Catia is done. Just making the box and the hole through it. Okay. And then, for example, we can say what kind of analysis we want. We want a static analysis. There is something called static RICs. You don't have these things in Catia because the only thing that you have is pretty much static and dynamic and all linear. Okay, these they're not. Most of them are not in Catia. But anyway, let's do a static problem. It's a very simple problem. I'll just take all the default values here. And boundary conditions. Boundary condition is basically your restraints. For example, we did this problem. So let's put a surface slider here. Okay. Now, Catia does not, I mean, this guy, they don't call it surface slider anymore. Okay. Roller will work, but there's something called symmetry. Where's the symmetry one? Planar symmetry. Remember, we put surface slider on planes of symmetry. So why don't I use this? Or perpendicular to it is 0. That's all it does. So planar symmetry, this was a planar symmetry. You don't get the roller icon anymore. You get something that's terrible. Another one, you have to do these separately, obviously. In Catia, you have to do it. You can do it all at once, but not here, for good reasons. And which one is the other one? Which one is the other planar symmetry? I did the bottom and the back side, for example. Which one is the other one? Yep, this one, right? This one? Yep. Okay, so planar symmetry right here. Okay, good. And then load. Then the load. So load on the load, you can do force, you can do pressure, and there are other things you can do. So for example, let me put I don't know, a force on that face, magnitude in the direction y, 1,000 pounds. Remember, if I'm doing a force, the actual force on the structure is 4 times this. This number that I put there is 1/4 of that 4,000. Okay, if it was 4,000 on the entire structure. And then we say, okay. And since I know everything is going to work fine, I'm not going to do on the simulation. Remember, Catia has a run calculator, or what does it say? Compute the calculator, right? Uh, I'll do the last one, which is simulate, because these are to check, make sure nothing critical is missing, and they're going to report to you. You don't want to run something and then find out something was missing. So I'm going to run it because this is such a simple problem that it makes no difference. And I'm going to repeat the same problem with shell elements because, after all, this can be done with shell. Yep, number of cores and all that stuff. I have no idea. I don't know. This is a very simple problem. It happens in one step. Actually, yeah, one step. One of the reasons that it may take longer than ordinary Catia is, of course, this is a better program. There's no doubt about it. But the results that are created are stored automatically on the server. In my case, it's a Europe service server, so uh, communication. Okay, so that could be a factor. Done. It's one step, as I said. This is the no. This is basically the before the load is applied. Everything is zero. This is after the full load is applied. The biggest stress is at the bottom. You expect bottom is here, okay, etc. And then you can do displacements and generate stuff that is not easy to do in Catia. In Catia, if you want some stuff generated, it's not automatic. You have to create Excel files, import it, do the graphics, plotting, and things like that in Excel. Yeah, I'll be with you in just a second. Here's the deflection, the biggest deflection at the end because you're pulling it on both sides. Yeah, yeah, yeah. Better go and review this stuff for tomorrow. You put 4,000 pounds on that face. Once you take 1/8 of the part, that 4,000 pounds is on how many planes being applied? 1/8, you're right. You're absolutely right. But that 4,000 pounds at the end, on how many planes was it being applied before we took the symmetry? Like if you count about the number of things that's being applied, there are four of them. So don't go by the fact that I took 1/8 of the model, I should take 1/8 of the load. You know, I took half of the model, I have to take half of the load. Look at your problem. You had 4,000 pounds. You had 4,000 pounds applied here. You divided this into 8 pieces. Now this 4,000 pounds is applied only on these four faces, 1/4. Okay, good. Any questions? Any other questions here? All right, that being the case, I'm going to say, okay, let's kill this. I don't want to save anything. The good thing is that even though I say, I don't know, actually, sometimes I said don't save anything. I closed these things automatically. Everything was there, so it was saved already. Yeah. Okay. So let's do the same problem, and I'm not going to use symmetry anymore. Maybe I should use. I'll use symmetry. Same problem. Uh, but I'm going to model it as shell. Okay. Because after all, when you think about it, yes, I drew it as solid. I did draw it as solid. But if somebody did this problem as a shell for me on the test, I would accept it. Better be all right. Because the most appropriate element can be shell or can be solid, depending on what you want. Shell obviously is not going to give you the whole picture, but it is very appropriate. Okay? Remember, the whole idea of a shell is that there's no stresses in the depth direction. If you took this body and pulled it, there is no stresses in the depth direction, very little. That's why we assume. So that's why shell is perfectly okay. All right. Now, so let's start with the generative shape design. You're familiar with that? On the very top, it says Catia, generative shape design. Okay. And a convenient plane, on that vertical plane, I will sketch a quarter of that guy, a quarter of this rectangle with a hole in it. So let's do that. I'm going to try not to waste a lot of time on this. Cancel. I wanted to center it. All those things with fixing restraints and things like that, it's exactly the same thing. Okay? So let me make a circle here. That's a gigantic circle. Okay, that's fine. Now, the reason I say that's a gigantic circle is that the size of these things matter because the smaller the size, uh, let me ask you a question. Would you say the smaller the size, but we know what the critical points are, top and the bottom, when you pull it like that, top and the bottom. But the size, if the size gets smaller, the size of the circle gets smaller, would the stresses on the top and the bottom increase or decrease? What would you say? Okay, I'll let you go and review your notes. Okay, I'm asking this. I have a size, I have a part this size, loading it, you get a top and the bottom, big stresses. In this case, bottom, there is no bottom because we're not modeling it. If the size is smaller, if the size of the circle is smaller, would the stress at the top increase or decrease? These are perfectly legitimate questions to ask for 1 point. Yeah, it's not going to hurt your grade, but I want to be able to distinguish between somebody who can answer. Not that I care, but it's just that your grade should reflect that. Anyway, let's move on. Let's do a cleanup. A cleanup. So there must be something quick trim right here. Quick trim. Right, see the eraser. I think it was an eraser there too. So click on it. This guy goes. This guy goes. Oh, come on. There. I was taking the axis. I was selecting. What do I have here? Why is it not taking that? Yeah, good. Because I clicked on it once. When you click on it once, even Catia closes that quick trim. If you click on it multiple times, you can select multiple lines. That's what happened. Good. Exit. Exit. Under what you see, you have essentials, of course, and you have surface. And now volumes, you don't have it in Catia. In Catia, if you go to generative shape design, you cannot do volumes, solid objects, basically. Here you can. They don't call it solid because it's not the same thing, but you can create and do solids with in in generative shape design here. But it's not the same as part design. That's different. But I don't want to do that. I want to go create a surface. Let me remind you how many ways you can create surfaces. You can do extrude, revolve, and these are primitive shapes, a sphere and cylinder and things like that. And then we want, what do we want to do here? How do I put a surface here? What is that? Fill, exactly. Yep, right there, fill. Close, a closed curve. You can do a fill, and hallelujah. There we are. Okay. Now we already have a material, so let me take the same material. I'll go to tools, and under material, I'm going to say material browser. I use the same one, June 16. From this point on, it has nothing to do with Catia anymore. Catia is done. Okay, June 16, right click, apply on that part, and it's right here. You can always check it if you want. You can always check it. If you double click on it, this is the stuff that I inputted. Okay. We're done here, so we're going to go to meshing. First, you mesh it. It'll give you, I'll do the standard one. It'll give you the options that you have. It'll give you the options that you had in Catia, which is surface triangle measure. This is the same thing that you did in Catia, or the nice thing that you used to do in advanced meshing tool if you had to. Right there, I'm going to select this. Size, I put 4 millimeter. I don't know. We'll see how it goes. There. And if you don't want to see the part, for example, or your mesh, right-click Visibility Manager, basically hide and show and things like that. For a while, I had a hard time understanding what these things were. And I with a cross on it means hide. So hide the part, show the part, hide the mesh, show